Right, here we have a Poisson distribution question because the large fires have occurred at the rate of 9 per year. So because it's Poisson, we can say that x, the number of fires, has got a Poisson distribution, and the null hypothesis is going to be that lambda is 9, and the alternative hypothesis is that lambda is greater than 9, because we've got to see whether the rate has increased. So it's a one-tailed test. Let's use a 5% significance level. We're not told anything else. So we need to find what the probability is of getting 16 or more. And that is obviously 1 minus the probability that it's less than or equal to 15. We can look that up in tables. So it's 1 minus 0.9780, which is 0.0220. Now that's less than 5%, so the probability of this happening is so small that we can't really believe that the rate is still 9. So the null hypothesis is rejected, and then we need to write a sentence to conclude it, which is within the context of the original question. So there is sufficient evidence to conclude that the rate of large fires has increased. Here's another example, but this time it's going to be a two-tailed test, because what we've got is a binomial distribution. Because we've got success or failure, we've got 150 attempts, and the null hypothesis is that the probability is 1 in 20, or 0.05. Now the question specifically says, can I conclude that the network maintenance has made a difference? So it might make it better, it might make it worse. So the alternative hypothesis is that P is not 0.05. We've got 5% significance level. Now, we can use a Poisson approximation, so we can say that x is approximately got a Poisson distribution with 7.5. That's because lambda is 150 times 0.05, which is 7.5. That's an equal sign there, there we go. So what's the probability that x is less than or equal to 2, because we got 2 successful attempts in the first 150. Now looking that up in Poisson tables, we get 0.0203. Now it's a two-tailed test. We could also reject the null hypothesis by getting a number much bigger than 7.5. And so there are outcomes like 2 which are more than 7.5. So as we've only got the probability for some of the outcomes which are like 2, we need to double this. 2 times 0.0203 is 0.0406, which is less than 5%. So it's a two-tailed test because has it made a difference? This is only giving us one tail, so we need to double it to get the second tail. So because of this, we can reject H0, and then we can write a sentence in the context of the original question. And although it might be tempting to write a different conclusion, what we were asked to explore was, has the maintenance made a difference? And so there is enough evidence to conclude that the maintenance has made a difference. Here we've got a question about under 18 conception rates. We've got a rate of 173 per year, so we can say that the number of conceptions has got a Poisson distribution, and the null hypothesis is that lambda is 173, so the alternative hypothesis is lambda is less than 173. It says we have to explore whether the conception rate has decreased, so this is a one-tailed test. Let's use 5% significance level. Now we can't look up lambda is 173 in a Poisson distribution, the tails only go up to 10, and we could work out all the probabilities from 0 to 173, but it would take several years. So let's use a normal distribution, a normal approximation. So the mean is lambda, the variance is also lambda, so we've got a new variable y which belongs to the normal distribution 173, 173. And what we want to know whether x, or probability of x being less than 149, which is approximately the same as y being less than 149.5. We need to have the continuity correction because the normal distribution is continuous. So this means we need to find the probability that z is less than or equal to 149.5 minus the mean over the standard deviation. In other words, what's the probability that z is less than or equal to minus 1.79, and by symmetry that's 1 minus the probability that z is less than 1.79. That's 1 minus 0.9633, so that's 0.0367, which is less than 5%. So we can now reject H0, H0, the null hypothesis, and write our conclusion. And there it is. There is enough evidence to conclude that the under 18 conception rate has decreased.